So, welcome to today's lesson. On today's lesson, we are going to learn how to discuss the stability of scalar differential equations, and we are going to illustrate that with this particular example here. So, the keywords here is the keywords here are like what's a scalar differential equation? So, a scalar differential equation is of this form. Is a differential equation of this form. So here you should know that x and t represent any variable. So someone can write dy dt equals f of y or anything. So any differential equation of this form is a scalar differential equation. And mostly when you have a scalar differential equation, before you can discuss its stability, you have to find its fixed point. So you always have to find the fixed point of your scalar differential equation. And in some book you see equilibrium point. Others will give you stationary point, and others will give you critical point or critical values. So in finding the fixed point of a scalar differential equation, let's say dx dt equals f of x, what we do is that we put dx dt to 0, then we get 0 equals f of x, and we solve for x. So that means that our fixed point becomes the value for x. So let's say s equals s star, where s star is the fixed point. So before we can discuss the stability of a scalar differential equation, we always have to find the fixed point. And that's how we find for our fixed points. After finding for our fixed point, then the next thing is to discuss the stability of it. And you know that from dx dt equals f of x, these are f of x. So we take this our f of x and we find the first derivative of f of x to get f prime of x. And when we put in our fixed point and the functional value here is greater than 0, then we see that our fixed point is unstable. If our if you put our fixed point in here and we get something which is less than 0, then we say our fixed point is asymptotically stable. And when our fixed point is equal to 0, then it is inconclusive. So we can't conclude whether the fixed point is stable or asymptotically stable or unstable. So back to our question, we had dy dt was equal to k y minus a. So we are supposed to discuss the stability of this scalar differential equation. So usually the first thing we have to do is to find for the fixed point. So the first thing we do is to find for the fixed point. In finding for the fixed point, we put dy dt to 0. So that means you're going to get 0 will be equal to k y minus a, meaning k is equal to 0 or y minus a equals 0. So that means y is equal to a. So that means our fixed point here is this particular letter a here. So after finding for our fixed point, the next thing is that we ask ourselves, what is our f of y? So you see in this case, it is f of y. So our f of y will be k y minus a, which is the same as ky minus ak. So we are supposed to find the first derivative, which is respect to y, and this is going to give us k. This part goes to 0. So to discuss the stability, then we put our fixed point inside. So we realize that we have f prime of y equals k. So our fixed point, we had it to be y star was equal to a. So you realize that f prime of a, our fixed point, will be equal to k. It doesn't change anything here. So you see here we have a k, and you know that k is a parameter. So because k is a parameter and k can take values from negative infinity to infinity, we can't tell whether our fixed point is unstable or asymptotically stable. So that means we have to consider certain cases. So when we consider when k is greater than 0, that means our f prime of a will also be greater than 0, meaning that here our fixed point is going to be unstable. So that's when we consider k being greater than 0. And when we consider k being less than 0, that means our f prime of a will be less than 0. So this means we are going to have asymptotically stable. And when we have our k being equal to 0, that means our f prime of a will be equal to 0, which means that we are going to have an inconclusive, the first point is going to be inconclusive, so we can't conclude whether it is unstable or asymptotically stable. So there is it with finding the fixed point of scalar differential equations. Thank you.